Okay, so as we start entering into concentration, we get into our calculation pieces. So you're going to find that in this video, we are going to look at calculating concentration with PPM, PPB, and percent by mass. Okay, these are part of the program of studies. We do need to cover them in Chem 20. However, you're going to find that they are not the calculation that we tend to do for the majority of our stuff. Okay, most of the stuff we're going to do is going to be our molar concentration, which you'll look at in the next video. So when it comes to concentration, concentration basically describes to us how much solute is present within a particular amount of solution. So if we're talking qualitatively, we can talk about solutions as either being concentrated or dilute. And that's basically indicating how that solute to solvent ratio looks. So a concentrated solution, we have a lot of solute within that solvent. And in a dilute solution, we're going to have very little solute present in that solvent. So first calculation we are going to look at today is going to be to calculate concentration as percent by mass. So when we are looking at calculating as a percent by mass, we're always going to take the mass of the solute in terms of grams, and we're going to divide it by the mass of the solution in terms of grams, and we're going to times it by 100, right? So similar to when you guys are trying to figure out a mark on a test, you take the mark you got, the mark you could have gotten, and then you times it by 100. So same idea here, okay? So looking at some examples, for the most part, this stuff is pretty straightforward. It's just a matter of plugging your givens into the equation and solving. Biggest challenge is these equations are not in your data booklet, so you do have to make sure you know them. The nice piece is, out of the three equations that we're going to look at today, they all have mass of solute over mass of solution as a common point. So really all you have to remember different is this part. And timesing by 100, you should be able to remember for a percent because you calculate percents all the time and you times by 100. Okay, so first example. We have 100 grams of seawater, contains 0.129 grams of magnesium ions. What is the concentration expressed as percent by mass? So what we have been given in this question is the mass of the solution. I'm just going to write it as SOLN for solution because it's shorter and it's more efficient. So mass of solution, it's the seawater. We have 100 grams. Okay, then we have the mass of the solute. There isn't really a shortened version of solute, sorry. And it is 0.129 grams, right? That's how much of the magnesium ions we have. So those are our knowns. We are attempting to determine the percent by mass, right? So we have our equation, which is that the percent by mass is equal to, oh, don't shut down on me, computer. All right, it is going to be the mass of the solute over the mass of the solution. And then we are going to times that by 100, right? And that's going to give us our percent. So we're trying to find the percent by mass. We have the mass of the solute. We have the mass of the solution. We obviously have this 100, so we have everything we need to calculate it. So we're going to say that this is equal to the 0.129 grams divided by 100 grams, and then times our 100 to get that as a percent. So significant digits, this had 3, this has 3, our answer gets to have 3. So 0.129 divided by 100 times 100, don't need a calculator for this, although I could, is going to be 0.129%, okay? So the only way we're really going to change this question up is maybe we're going to give you the percent and give you the mass of the solution, ask you to determine the mass of the solute, right? We could change what we give you, make you rearrange the equation, but for the most part, it's usually relatively straightforward. So the next calculation is concentration as parts per million, so PPM. So you'll often see PPM, like if you look on the side of a water bottle, you'll see that it give you all the different ions and things that are inside of it, and usually it'll say so many PPM. So PPM stands for parts per million. So what this means is if I had 1 million parts or pieces or particles or molecules, how many of them are my actual solute? So generally we use PPM for small concentrations. So our equation is PPM is equal to the mass of solute over the mass of the solution, both in grams, right? This is the same as what we saw for percent, but now we're going to times by 10 to the 6. Why 10 to the 6? Because that's 1 million. right? If we're trying to find parts per million, we need times by a million. So we're going to times it by 10 to the 6 ppm, and that is going to give us an answer in terms of ppm. So we're looking at an example. So hard water in Alberta contains up to 300 parts per million of calcium carbonate. So what this question has given us is the ppm. It tells us that it's 300. So that's one of our givens. Then it says how many parts per million are present in 20 liters of water. So the water is my solution. So the mass of my solution. So this is an important thing to recognize. You'll notice this gave me 20 liters. Okay, one of the things you need to make sure you are aware of when we are in the solutions unit is that 1 milliliter of water is equal to 1 gram. So if I have 20 liters, that's the same as saying I have 20,000 milliliters, which is the same as saying that I have 20,000 grams. Okay, so either I can write it like that, or I can just write it as 20 times 10 to the 3, right? Because that's generally how we convert over, is using that scientific notation, grams. I could also write this as 2.0 times 10 to the 4 if I want to. That's technically the more appropriate scientific notation, but often when we are converting the units, we won't actually do that, okay? So we have this. You also could have written this as 20,000 grams. So the only reason I didn't write it as 20,000 grams is sometimes when you guys do that, you throw yourself off for significant digits, and then you think that all those zeros you added in count. They don't actually count. You added them to be able to move that decimal place over. So you can write it as 20,000, but please recognize that those 3 additional zeros you tacked on at the end don't actually count for significant digits, okay? So this shouldn't say how many ppm are present. This should say how many grams are present, right? We already have ppm. We don't need to solve for ppm. So next thing we have is our equation, right? We know that ppm equals the mass of the solute divided by the mass of the solution times 10 to the 6 ppm. So in this case, we can't just plug right into the equation because what we're trying to solve for is the mass of the solute. So we need to isolate that. So we're gonna have to move some stuff around. So right now we're timesing by 10 to the 6 ppm. To move that over, we're going to have to take this and we're going to have to divide it by 10 to the 6 ppm. Right, and in doing that, we can get rid, of this. Okay, then the next thing to do is, again, we just want mass of solute. We need to get rid of mass of solution. The way to get rid of mass of solution is to multiply by it. So we're going to go over here. I'm going to do mass of solution times. And in doing that, we can now get rid of it over here. So we've rearranged our equation so that the mass of the solute is equal to the mass of the solution times the parts per million divided by the 10 to the 6 ppm. Okay, so now that we've rearranged it, we can plug our numbers into it. So the mass of the solution we have as 2.0 times 10 to the 4 grams. We are multiplying it by the parts per million, which was 300 ppm. And then we are dividing by 10 to the 6 parts per million. Okay, once we do that, we can plug this into our calculator and get an answer. So 2 times 10 to the 4 times 300 divided by 10 to the 6. And I'm going to get 6 on my calculator. But that doesn't have enough significant digits. That only has 1, so we're going to go 0.0 grams. Okay, so 6.0 grams. And that is how we're going to solve it. So pretty simple equation, rearrange it to solve for what you want. Make sure you throw your units in because that helps you identify that you've rearranged the equation properly, right? Because the ppms cancel, I'm left with grams. Okay, this is especially true if you know you struggle a little bit with rearranging equations. Make sure you put that in, okay? So last calculation is parts per billion. So this is for really small concentrations. We have mass of solute divided by mass of solution, and we're going to times by 10 to the 9, and that's because that's a billion, okay? So example-wise, it doesn't really look that different from what we've looked at before. Okay, this one is a little bit different though. So it says if the percent by mass of a solution is 0.25%, what is its concentration in terms of parts per billion? So this question actually requires you to take the two separate equations and analyze how they can go together. So if we think about those equations, we have that the percent by mass is equal to the mass of the solute divided by the mass of the solution, and then that was times 100. Then we had our second equation for parts per billion, which was that PPB is equal to mass of solute over mass of solution times 10 to the 9. So if we look at these, we have some common parts to these equations, right? This is exactly the same as this is, right? So if you think about when you're in math and you have two equations and one has x and one has y, you're trying to solve. What we usually do is we take one equation and we arrange it so that we can say x equals or y equals, and then we go to the other equation and we sub that in. Well, we're going to do the exact same thing here, right? We can rearrange these equations so that we say that the percent by mass divided by 100 is equal to the mass of the solute over the mass of the solution, letting us get rid of this, right? We moved that 100 over, and I can do the same thing over here. I can take this 10 to the 9, and I can move it over here, and I can divide by it. And so now I've made it so I have mass of solute over mass of solution for both of them. And I say that the percent by mass over 100 equals PPB over 10 to the 9 PPB. So now I can combine those together. And I can say that the percent by mass over 100 is equal to my parts per billion over 10 to the 9. I don't want that underlined. Over 10 to the 9 parts per billion. So looking at the one given, I was given in the question, I was given the percent as 0.25. So I can say that 0.25% divided by 100 is equal to, everything is now going in as underlined, my parts per billion divided by 10 to the 9. And now I can solve this, right? I have my one unknown, which is PPB. So I can do my 0.25% times 10 to the 9 divided by 100. And I can figure out how many parts per billion that percentage corresponds to. So 0.25 times 10 to the 9 divided by, hold on, my calculator's doing weird things, divided by 100. So I get a huge number, which kind of makes sense because 0.25% isn't a crazy small thing, and usually we use parts per billion to describe really small things. So we're going to have to go to scientific notation. So we're going to get 2.5 times 10 to the 1, 2, 3, 4, 5, 6 parts per billion. Okay, so questions that require you to relate them, you need to rearrange it so that you get mass of solute over mass of solution in both of them, and then you can combine those two equations to generate one equation. Okay, and then that is going to conclude the PPM, PPB, and percent by mass. Next video you're going to watch is going to be on molar concentration.